Hello everyone, this is Mr. Meter and we are here again with another video on a brief explanation of initiating a connection in HDLC communication, the AARQ and AARE sections. In a connection between two network nodes, imagining like device A wants to connect and communicate with device B, first the two nodes exchange SNRM and UA packets and then exchange AARQ and AARE packets. In this video, I will not be sharing my my video, because the content of the video is literally too much. So having me on the screen will limit the area in which I can provide details. Okay, let's talk about the AARQ and AARE packets. What is AARQ? The AARQ or Association Request packet is a crucial part of a DLMS communication process. It's like the friendly handshake that happens when two devices, say a smart meter and a monitoring platform, want to start chatting. When a DLMS client, or meaning the monitoring platform, wants to establish communication with a DLMS server, usually a meter, it sends an AARQ packet. This packet contains essential information about the client's identity, supported security mechanisms, and other relevant details. The AARQ packet structure is as follows. It contains the client system title, which is a unique identifier for the client system. Authentication mechanisms, which specifies how the client will prove its identity, for example, using a shared secret or certificate. Security suites describe the encryption and the integrity protection methods supported by the client. The client max receive, the PDU size, indicates the maximum size of data packets the clients can receive. The application context name identifies the specific application context, usually COSAM, for this communication. And the last two, the calling AP title and the called AP title. The first one is the title of a calling application, which is the client, and the last one will be the title of the called application, which is the server or meter. If everything aligns, the meter responds with an association response or AARE packet, confirming the association and providing additional details. Consider this, that a successful AARQ establishes a secure channel between smart monitor and echo meter. Now they can exchange metering data, control commands, and other relevant information. In the AARQ packet, the authentication mechanism is sometimes called the mechanism name. The mechanism name in AARQ or Association Request packet refers to the mechanism used for authentication and security within the DLMS communication protocol. This mechanism is specified as a part of the authentication information exchanged between the client, the requesting device, and the server, meaning the meter or the device being accessed. Here's how mechanism name is typically represented and used in the AARQ packet. Okay, the first part is the field location. Mechanism name is part of the authentication information within the PDU or protocol data unit of the AARQ packet. It follows specific encoding rules defined in the DLMS COSAM standard. Purpose is the second part, which in the mechanism name identifies the cryptographic mechanism or protocol that will be used for securing the communication between the client and the server. It ensures that both sides agree on common method for authentication and possibly encryption, depending on the security requirements defined in the application context. The possible values. The actual value of mechanism name can vary depending on implementation and security policies. Common mechanisms defined or specified in DLMS COSM include the low-level security mechanisms and the highest level security mechanisms. The low-level one is like, for examples include like mechanism based on shared secrets, for example, passwords or symmetric keys. And the high-level mechanism examples include mechanisms based on public key cryptography, for example, like certificates, digital signatures, for stronger authentication and secure communication. The fourth part will be the encoded format. Mechanism name is typically encoded using specific codes or identifiers within the AARQ packet, ensuring that both the client and the server can interpret and negotiate the security mechanism properly during the association setup process. In the negotiation part, during the association establishment, the client, which is initiating the AARQ, specifies the preferred mechanism name it supports. The server responding with the ARE then selects a compatible mechanism based on its capabilities and the security requirements configured for the application. In summary, a mechanism name in AARQ packet plays a crucial role in establishing secure communication channels between DLMS COSM devices by specifying the authentication mechanism to be used during the association setup phase actually. It ensures interoperability and adherence to security standards defined within the DLMS COSM framework. Okay, let's talk about the components of security suite in AARQ packet. The authentication value, which is a part of the authentication mechanism, contains the credentials or tokens used to authenticate the entities. It ensures that both parties are who they claim to be. The authentication mechanism name specifies the method of authentication, such as passwords, digital signatures, or other schemes. The encryption part, which contains like the encryption algorithms and the keys. The algorithm specifies the encryption methods used to protect the data. Common data algorithms include AES, DES, and RSA. Encryption keys contain the keys used actually for encryption. These keys are securely exchanged between the entities to ensure data confidentiality. The integrity protection check value, these are cryptographic hash functions or message digests like SHA 256 applied to the data to ensure it has not been tampered with during the transmission. The access control information specifies the access rights and permissions of the entities. This ensures that only authorized entities can access certain resources or perform specific actions. The digital signatures ensure that the sender of the message cannot deny having sent the message. This is important for accountability and audit trace. For example, let's do an example on the AARQ packet with a security suite. The first part will contain the protocol version that indicates the version of the ACSE protocol. The second part, application context name, specifies the context in which the association is being established. The third part is the called AP title, the address of the entity being called. And the fourth part will be the calling AP title, the address of the entity making the call. Authentication value contains the credentials for authentication. User information contains any additional information required by the application. And the latter part, or the last part, is the security suite, which by itself contains like five, or for example, five options. The first, like suit authentication mechanism name, for example, like password based. The second part will be the encryption algorithm, for example, the AES 256, and integrity check algorithm, for example, the SHA, again 256, access control information, for example, being read-only or writable, and the last one, the digital signature, which is a signature ensuring non-repudiation. The security suit in an AARQ packet is crucial for establishing a secure and trustworthy association between two entities in a network. It encompasses various mechanisms like authentication, encryption, integrity protection, access control, and non-repudiation to ensure the security and reliability of the connection or the communication. Let's talk and delve deeper into the AARQ packet and talk about the calling authentication. In an AARQ or association request packet, the calling authentication mechanism is crucial for verifying the identity of the entity that is initiating the association request. This process ensures that the requesting entity is legitimate and can be trusted before establishing a secure connection. Here's the detailed description of calling authentication in an AARQ packet. The calling authentication mechanism, calling authentication packet, actually contains at the first part the authentication mechanism, which we talked earlier. This field specifies the method used for the authentication. Common mechanisms include like password-based authentication, public key authentication, token-based, and certificate-based authentication. The first type is simple and widely used but less secure. The second one, which is the public key authentication, is more secure and involves this use of public and private key pairs. The token-based uses security tokens issued by a trusted authority. The certificate-based authentication uses digital certificates issued by the certificate authority or the CA. The authentication value. This field contains the actual credentials or data used for authentication, which can vary based on the mechanisms chosen. It can be password or a digital signature or a token. The password, let me slide this back. The password, if using a password-based authentication, this field will contain the password, often encrypted or hashed. The digital signature for public key or certificate-based authentication, this field will contain a digital signature. If using a token-based authentication, this field will include the security token. So this field actually is, as it says, the authentication value. The mechanism name, which we will just go past by, is the optional field. It specifies the name or identifier of the authentication mechanism used, helping both entities understand and agree on the method of the authentication. Okay, steps involved in a calling authentication. The first step is initiation. The calling entity prepares an AARQ packet with its identity information and chosen authentication mechanism. Next, the credential inclusion. The calling entity includes its authentication value in the AARQ packet. For example, if using a public key authentication, it would include a digital signature created using a private key. The transmission. The AARQ packet with the authentication value is transmitted to the called entity. Upon receiving the AARQ packet, the called entity extracts the authentication value and verifies it. If a password is used, It checks the password against its records. If a digital signature is used, it verifies the signature using the calling entity's public key. If a token is used, it checks the validity of the token. The response. If the authentication is successful, the called entity proceeds with establishing the association. If the authentication fails, on the other hand, the called entity may reject the association request and send an error message or an association response, reject ARE packet. Okay, the importance of the calling authentication and ARQ packet is for the security, trust, and accountability. On the security part, it ensures that only authorized entities can initiate associations. On the trust, it builds a foundation of trust between communicating entities, and on the accountability, provides a mechanism to trace actions back to authenticated entities, which is important for auditing and non-repetition. By implementing robust calling authentication mechanisms, organizations can significantly enhance the security and reliability of their network communications. Okay, client max receive PDU size. The client max receive PDU size in an ARQ or association request, as we are talking about, is a critical parameter that defines the maximum size of a protocol data unit or PDU that the client is capable of receiving. This size is typically expressed in bytes and helps ensure that the server does not send data packets larger than what the client can handle. The purpose of the client max receive PDU size is as follows as we are going to talk about it. The first one is the memory management. The parameter allows the client to control how much data it can receive at once, preventing scenarios where the server might send a PDU that is too large for the client to process or store. The efficient communication. By specifying the maximum PDU size, the client ensures that the data transmission is tailored to its capabilities, which helps in maintaining an efficient and stable communication session. Avoiding buffer overflows. Specifying this size helps avoid buffer overload issues, where the client's buffer might overflow if the PDU size exceeds its capacity, potentially leading to crashes or data corruption. The negotiation part. During the association setup, this parameter is communicated to the server, which can then adjust the size of the PDUs it sends, ensuring the compatibility between the communicating entities. Example in an AARQ packet. Here is an example of how the client max receive PDU size might be represented in an AARQ packet. In this example, the client max PDU size is set to 8,192 bytes, indicating that the client can receive maximum of 8192 bytes in a single PDU. How it works in practice. The client sends an AARQ packet and the server processes the association packet. The data transmission is done and the adjustments are done on it. The first part is when the client initiates an association request that includes the client max receive PDU size in the AARQ packet. The second part, upon receiving the AARQ packet, the server reads this value and ensures that any PDUs it sends to the client does not exceed the specific size. During the communication session, the server sends PDUs within the specified size limit, ensuring that the client can receive and process them without issues. This was the data transmission part. And the last one, which is the adjustment. If the server finds the specific PDU size too small for efficient communication, it may attempt to negotiate a different size or handle data in smaller chunks. Okay, the importance of the client max receive PTP size is vital in network communication protocols, where data integrity and efficient transmission are paramount. It ensures that the client can handle incoming data without being overwhelmed, thus maintaining the stability and reliability of the communication session. Okay. The application context name. The application context name in an AARQ or association request packet is crucial parameter that defines the context or environment in which the association between two entities, such as a client or server, will operate. The context typically specifies the set of services, protocols, or operations that are expected to be used during the communication sessions. Okay, the first part is defining. Actually, let's talk about the purpose of the application context name. The first one will be the defining of the operational environment. The application context name identifies the specific application or protocol framework that the association will use. This ensures that both the client and the server are aligned on the expected behavior and capabilities of the communication session. The next one is interoperability. By specifying the application context name, the client and the server can ensure that they are compatible in terms of the applications they support. For example, in healthcare systems, using the DCOM standard, different application contexts might be used for different types of medical imaging data. Protocol negotiation. The application context name helps in negotiating the use of specific methods and protocols or services. If the server cannot support the requested context, it may reject the association or suggest an alternative context. Service definition. It defines the services and operations that will be available during the association. This might include specific commands, data formats, or transaction types that are relevant to the application. Service definition. It defines the services and operations that will be available during the association. This might include specific commands, data formats, or transaction types that are relevant to the application. Example in an AARQ packet. Here's how the application context name might be represented in an AARQ packet. In this example, application context name, the one that you see 128.84.0 blah blah blah, represents a specific application context. In DCOM, for instance, this might refer to a particular service class for image storage or retrieval. How it works in practice. Okay, the first step will be the client specifying the application context. When the client initiates an association request, it includes the application context name in AARQ packet. This name is usually an object identifier or an OID that uniquely identifies the context. Okay, the server validating the context. The server checks if it supports the specified application context name. If it does, the server proceeds with an association under the context. If not, it may reject the request or purpose an alternative context. Establishing the association. If both parties agree on the application context name, the association is established and all subsequent communication adheres to the rules and protocols defined by the context. Context-specific operations. Once association established, the client and the server exchange PDUs that are specific to the agreed upon application context. This ensures that both entities understand the data and operations being performed. The importance of the application context name is that it's essential for ensuring that both the client and the server are on the same page regarding the services and protocols to be used during the communication. It helps prevent misunderstandings and ensures that the association is conducted within a mutually understood and supported framework, which is critical for the successful execution of networked application, especially in complex environments like healthcare, finance, or industrial systems. The calling AP title. The calling AP or application process title in an AARQ packet is a key parameter that identifies the entity such as a client or an application that is initiating the request to establish a communication session with another entity, usually a server. This title serves as a unique identifier within the network, allowing the receiving entity to recognize and authenticate the initiator of the association. The purpose of the calling AP title contains of 4 essential parts. First one is the unique identification. The calling AP title uniquely identifies the client or application that is requesting to establish the association. It helps the receiving entity know exactly who is initiating the communication. The routing and addressing. It assists in routing the association request correctly within the network, ensuring that responses and data can be returned to the correct client. The access control and authentication. The server can use the calling AP title to apply access control policies and authenticate the client. This is a part of the security framework to ensure that only authorized entities can establish associations. The fourth one is the session management. In environments when multiple sessions or associations may be active simultaneously, the calling AP title helps in distinguishing between different clients or applications, aiding in proper session management. The structure of the calling AP title is as follows. The calling AP title is typically structured as a unique name or identifier, depending on the specific protocol or system. It could be like a human readable name, an object identifier, or a distinguished name. On the human readable name, it will be a string representing the name of the application or entity, such as like client app 1. An object identifier or an OID, a numeric identifier that uniquely identifies the application process within a global or organizational context. A distinguished name, or a DN, in environments like LDAP or X.5, it could be a DN that represents the calling application process. An example in AARQ packet. Here's an example of how the calling AP title might be represented in an AARQ packet. This is how it works. The client initiates the requests. When the client or application process wants to establish a communication session, it includes its AP title in the AARQ packet. The server processes the requests. The server reads the calling AP title to identify the client. This identification can be used to check if this client has the necessary permissions to establish the association. The authentication part. The server might use calling AP title in conjunction with other information like the authentication value to verify the identity of the client. And at last, the association establishment. If the server accepts the request, the calling AP title becomes the part of this established session, and any further communication is associated with this identifier. The importance of the calling AP title is that it's crucial for establishing secure, reliable, and well-managed communication sessions in networked environments. It ensures that the initiating entity is correctly identified, authenticated, and authorized, which is especially important in systems where security and proper session management are priorities, such in healthcare, finance, and metering systems, enterprise IT systems, and etc. By using a unique and well-defined calling AP title, organizations can better manage and secure their network communications. Okay, the called AP title. The called AP or application process title in an AARQ packet identifies the entity, typically a server or another application, that the client or initiating application is trying to establish a connection session with. This title serves as a unique identifier for the target entity within the network, ensuring that the association request is directed to the correct destination. Purpose of the called AP title contains of actually 4 parts. The target identification. The called AP title uniquely identifies the server or application process that is intended recipient of the association request. This ensures that the request is directed to the correct entity. The routing and addressing. In complex networks, the called AP title helps route the request accurately to the server or application, ensuring that it reaches the intended destination. Session establishment. The title is used to establish the context of the session. It helps define the scope and the nature of the communication that will take place between the client and the server. The access control. The called AP title can be used by receiving entity to enforce access control policies, ensuring that only authorized clients can request associations with specific services or applications. The structure of the called AP title is as follows. The called AP title is typically structured as a unique identifier, which can be formatted in different ways depending on the specific protocol or system in use. A human readable name or an object identifier or a distinguished name, and this is actually the same with the calling AP title, but the difference is for example in the human readable name it can be, for example, a server app 1 instead of client app 1, and the whole thing is the same. Example in an AARQ packet. Here's an example of how it's used. In this example, the called AP title, the server app 1, is a human readable identifier that represents the server entity the client is attempting to establish a communication session with. Okay, how this works in practice. A client prepares an AARQ packet. The client or initiating application process includes the called AP title in the AARQ packet specifying the intended recipient of the association request. Routing of the request. The routing part contains of the network or system using the called AP title to route the AARQ packet to the correct destination, ensuring it reaches the intended server or application. The server receiving the request. The server or application identifies by the called AP title receiving the AARQ packet and processes it, determining whether to accept or reject the association request. At last, in the establishing of the association part, if the server accepts the request, the called AP title becomes the part of the established session, allowing the client and the server to communicate under the specified context. The importance of the called AP title is crucial for ensuring that the association request is directed to the correct target within the network. It plays a key role in the routing, identification, and access control mechanisms that govern how communication sessions are established and managed. By correctly identifying the target entity, the called AP title ensures that the association is set up with the intended server or application, enabling the secure and efficient communication. Okay, we talked about the AARQ, but let's talk about the AARE packet, the association response. The AARE packet is a critical component in the association established process in various communication protocols, particularly in systems like ISO OSI model and certain healthcare standards like DCOM or DLMS. The AARQ packet is sent by the server or called application in response to an AARQ association request packet sent by the client or the calling application. The purpose of the AARQ packet has three main parts. The association response. The AARE packet is used by the server to either accept or reject the association request made by the client. Communication parameters. It contains the important parameters and settings that define how the communication session will be conducted if the association is accepted. The error handling. If the server rejects the association, the AARE packet will include the information on the reason for rejection or rejecting and allowing the client to understand why the association was not established. The key components of an AARE packet. The first one is the protocol version, which indicates the version of the protocol being used for the communication. The second one is the application context name. This is the same as the AARQ packet and indicates the agreed upon context or environment for the association. The third one is the result, which indicates whether the association request was accepted or rejected. Common values include accepted, rejected permanent, or rejected transient. Result source diagnostics provides additional information about the reason for the result, especially if the association was rejected. May include specific error codes or diagnostic information. The responding AP title. This one identifies the application process server or the server actually that is responding to the association request. It is equivalent to the called AP title in the AARQ packet. The calling AP title echoes the calling AP title from the AARQ packet, ensuring the consistency in identifying the client. And next one is the security parameters, which is optional. If applicable, it may include security related information such as authentication values or encryption parameters. The last one is the user information. This section may carry additional data specific to the application context or the protocol being used. It can include session parameters, application-specific data, or other relevant information. Example of an AARE packet. Here's an example of what an AARE packet might look like in a simplified form. In this example, the result is set to accepted and indicating that the server has accepted the association request. The result source diagnostic is success, meaning no errors occurred during the request processing actually. The responding AP title confirms the identity of the server that accepted the request. How this works in practice. The client sends an AARQ packet, and the client sending the AARQ packet to request an association with the server. Next, the server receives the AARQ and processes it. It processes the request and determines whether to accept or reject it. Next, based on the result of the processing, the server sends an AARE packet back to the client, indicating whether the association request was accepted or rejected, establishing the association. If the AARE packet indicates acceptance, the association is established and the communication can begin under the agreed upon terms. If the association is rejected, the client may take corrective action based on the diagnostic information provided. The importance of the AARE packet, that is, it's essential in confirming whether a communication session can be established between two entities in a network. It finalizes the negotiation process initiated by the AARQ packet, ensuring that both parties agree on the terms of the association and providing the necessary feedback if the association cannot be established. This step is a crucial step for maintaining the integrity and reliability of the communication sessions, especially in environments where data accuracy and security are paramount. Okay, let's look at a sample AARQ and AARE packet. This packet, as you see, is a packet that a client is trying to connect to a meter, an electricity meter. The highlighted parts are the ones that we're going to talk about. We are going to do analysis step by step. The highlighted parts contain the target address and the source address and the length of the packet and the frame type, which is the AARQ, and the PDU, which contains actually the association request we are talking about. The association request, which is highlighted on the left side, contains of the data here, as you see, and contains of conformance bits, proposed DLMS versions, and many other things that we discussed earlier. The association request starts, as you see, is and translated. I used, by the way, I used Guru's DLMS translator for translating the packet you see on the left, and you can also use that for translating your packets in HDLC, DLMS, and many other protocol formats. And as you see, it translates it into an XML-like tag version and makes it human readable. The association request contains of the application context name. I'll just cover the important parts. The mechanism name, as you see, it's low, and the calling authentication. And then it contains of the proposed conformances, the conformance bits. The conformance bits are simply the associations that you are requesting from the meter or the target. For example, you're requesting access on and get and set, or a selective access, or an action. And you're proposing next the max PDU size. Okay, the AARE answer, the answer that comes from the meter, and we highlighted the first part as same as the last packet we discussed. The highlighted part contains, you see, the length of the packet, the target and the source address, the frame type, which is ARE, and the value is 30, and the PDU, which contains the association response, or the ARE we are talking about. Okay, let's talk on the PDU side of the packet. Okay, after we translate it using GURUX, we have the association response, the application context name, the result source diagnostics, and the negotiated conformance bits. As you can see, the number of the conformance bits that are negotiated is lesser than the number that we requested, and it is normal because in general we request a general number of the conformances depending on the action we are going to do next, and the meters will respond with the lesser ones depending on the security level and what services they provide. And at last, the negotiated max PDU size. The meter is telling us that it's going to communicate with us with the PDU size of the 04C8. Okay, this was a brief explanation of initiating a connection in HDLC communication and the AARQ and the AARE sections. Please hit the subscribe button and we will be talking much more on the network protocols, transmitting data modes, and all about applications of data measurement and transmission in energy grids and metering industry. Also, please feel free to send all your questions and I will be making a video answering all your questions, or I will be answering them directly to you via email. Thank you.